a telescoping series has something really interesting happening. If you look at the sequence of partial sums, so if we look at S sub n here, or S sub 1, we'll start with the first term. So plug in 1 to both of these, and you'll get 1 over 2 to the 1 minus 1 over 2 to the 2. So that'll be 1/2 minus 1/4. And then S sub 2 will be this first term. So this is the first term here that we just had. And then you're going to add to that the next term. So plug in 2 into this guy, and you'll get 1 over 2 squared, which is 4, minus 1 over 2 to the third. So that'll be 8. And if you notice here, these two middle terms will cancel out because they'll just add together. So you'll really just have 1/2 minus 1/8. And then if we look at the third term, we'll have all of these that we've already calculated, plus the third term added in here. So plug 3 into here, and we'll get 1 over 2 to the third, which is 8, minus 1 over 2 to the fourth, which is 16. And then now we'll have the 1/4 will cancel, but the 1/8 will also cancel out. And so this will be 1/2 minus 1/16. So you can see with the telescoping, what's going to happen is all of the terms on the inside are going to end up canceling out, and you'll always be left with the first term and the last term. So we can easily write a formula for S sub n here, because it'll always be 1/2 minus the last term, and the last term will always be what you got from this. So 1 over 2 to the n plus 1. And if we use our definition and we take the limit as n approaches infinity of this, the bottom here will grow as we keep plugging in large numbers, so that will go to 0, and so we'll have 1/2 minus 0, which will be 1/2. So the sum of this will get closer and closer to 1/2, because you'll always have that 1/2 in the front, and then this number at the end is getting smaller and smaller and smaller. So as we keep doing more and more terms, the sum will get closer and closer to 1/2. So this series equals 1/2. So let's look at just kind of another example so you can see what's going on in these. So here, this guy, a lot of times what you have to do with partial sums, which is why this is Calculus 2 material, is you have to use partial fractions to break this up. So you would do like a over n plus b over n plus 1, and you would solve for your a and your b, and so you would have a times n plus 1 plus b times n, and that has to, remember, equal the numerator. So then if you plug in n equals 0, you'll get a equals 1, and then if you plug in n equals -1, you'll get a is equal to, or b, sorry, a will become 0, and then we'll have b, negative b is equal to 1, so b is equal to -1. And so this breaks down into 1 over n plus -1 over n plus 1. And when we have these fractions where we're adding and subtracting fractions like this together, that's when you'll see this telescoping series stuff type of happen. So let's look at the first term, first sum here. That'll be just the first term. So plug in, we're going to plug it, you can plug it into either one, but we'll plug it into this one to see the telescoping effect. So plug in 1 and we get 1 minus 1 over 2. Sum of the first two terms, so this will be the first term, that's what we just calculated, plus the next term, so plug in 2 into this, and you'll have 1/2 minus 1/3, and the 1/2s will cancel. That'll become 1 minus 1/3. S sub 3, the first three terms, so that'll be everything that we just calculated, plus the third term, so plug in 3 into here, and you'll have 1 over 3 plus, minus 1 over 4. So all these middle terms will cancel, and we'll just be left with 1 minus 1/4. And you can kind of see what's happening here, just like last time we had a 1 in the beginning of each of these, and then we're always left with the last term. S sub n will be 1 minus whatever the last term is. And the last term is always generated by this. So that'll be 1 minus 1 over n plus 1. And if we use our definition and we take the limit as n approaches infinity, as n approaches infinity, this fraction, the bottom will grow, and so that will go to 0, and we'll have 1 minus 0, which will be 1. So this series sums to be equal to 1. This converges and equals 1. So kind of cool concept, but not tested on the AP test.